Algebra 2B. Today is Thursday, February 2. At the very top of page 22, please write down this problem right here. It's not right there already.
Where we start at?
At the very top of 22.
X plus 6.
This is something that wasn't there, but I wanted to highlight it. You're right at the top of page 22. So write that down.
This on the assessment? This is not page 50. It looks familiar to
But at the very top, yeah, it's connected. There's a piece that I didn't give you and I felt bad about it. You're going to try and write down your zeros directly below the factored form. Right here at this table, I'm actually got to hold. You need to slip out and do it.
Saying lead.
But here's the deal. Put down your zeros below this one. It's the one with the 3 that I just want to remind you of. Since I don't feel like we did direct. Those weren't here to be good for you because standard 5. This will help you with that. For those who need to revisit standard 5, you'll be able to go back to it. The computer part of today's lesson will also help with the bottom portion of standard 5, finding the zeros. So let me have someone just kind of say. So this is next to this one, right? Factored. Factored as parentheses. You're getting the zeros that are below. Also called the x-intercepts. I'm putting both just because sometimes they'll ask, hey, please write down the x-intercepts. Sometimes they say, please write the zeros. Now, again, we're reviewing. We did some of this before, so all of this today is just a quick review just before I give it to you. Instead of me like, all right, here's your assessments. Yeah. So right now you're putting in your zeros. So right now, if you know what you're doing, these two are done. These two are done. It's this last guy here that's a little tricky. So there we go. Someone tell me the 0 for the positive 2. Negative 2 comma 0, no big deal. Somebody different. The 0 for the positive 4.
Negative 4, 0.
All right. And so the last part.
1 over 3, 0. 1 over 3, 0. 1 over 3, comma 0.
So this one here, it's true. You begin with the same +1, the same opposite sign. The 3. Goes below. If it was a 2, it goes below. If it was a 5, it goes below.
Your head's probably more.
Stop commenting.
Write that down. But technically what you're saying here is to find out what x needs to be so that this whole thing will equal 0. Technically, the way you're supposed to do it is you're supposed to write an equation. X plus 2 equals 0. You put the equals 0 in blank, that way it stands out. And then when you solve that equation, it's true, you just do minus 2, minus 2. You wind up with x equals a negative 2. Okay. For this guy here, technically what you're doing is the 3x minus 1 equals 0, because we want this whole thing to equal 0. And when you do the math work for that, you wind up doing a plus 1, which gives you a 3x equals a 1. And the last move you have to do is to divide the 3 on both sides.
That's
what I do. Alright. So that's why it's the... Yeah. But again, eventually once you get it, it's always the opposite number. And that extra piece is on the bottom. Alright, any question on these? It's just a reminder, when you get your assessment back, if you want to go peek back at standard 5, you can. Also, I think standard 2, I may do something with that. Alright, so let's actually try and get this final answer over here. Let me see. For page 22, the actual bottom, we're going to do this one here. I'm going to extend my page, but what I want you to write, which you'll need to write, your test may not ask for all of them, but you'll write down D for degree, O for orientation, S for number of solutions. Then you'll need your zeros, also known as the y-intercepts, so y-ints. They'll ask for the y-intercept, which normally you have to give yourself space because there's always going to be at least 3 zeros of x-intercepts. And then end behavior, which they have up here, but I'm going to put down here. So that on your test, when it's time for you to write, these are the pieces that you'll need to have. You'll do this version without the computer, and then you do the version with the computer. The difference between this version without the computer and the computer version is, in this version, and now I'll bring it back, they'll give you the factored form, and you just go down the list.
How do we get the y-intercept again?
And we're going to show that.
Alright.
And then the computer version, you'll plug it in to get your zeros, and you'll have to go up the list until finally you give the actual equation. Alright, so do this. Before I start saying anything, attempt to fill in any of it that you can, like if you know the degree, if you think you know how to get the orientation of the solution. You know how to get the zeros, so anyone who wasn't here last time, the zeros you get the same exact way we just did. Now I wish this list thing was up higher now that I see it to go up and down. So here's what I'm going to do. I'm going to put my list up here, that way I don't have to keep scrolling up and down. You keep yours where it is. So again, start filling in those, the ones you know how to do, but for sure everyone should know how to get the zeros. The y-intercept, calculators will help with that. Let me just, again, I'm going to write mine up here. You can write yours where it was. So again, degree.
I know he's comfortable. That's a high five.
Orientation.
Oh.
The solution.
I'm trying to learn. Listen, how fast?
Zeros. Accepted.
Oh, see, her hands are cold. See, her hands are cold. Hold on, so her hands are cold. Her hands are cold. Sometimes I feel like of nature.
Like that you just like that warm hands.
All right, let's get some help from you. There are 4 of them, so 1 for each table. I'll start with this table here. I'll ask for one. The first 0, the second 0, the third 0, the fourth 0, and then we'll come back up and pick up the degree and solutions, that stuff. But just since the zeros are so easy, we'll do that part here. All right, so here we go. So what's the first 0 of this table here? Yeah. So again, it's going to be guaranteed. Back table, the second 0, please.
Chicken 30.
Back there, the next 0.
0, 5.
All the same number up the sign, and the last one up front, please.
8,
8, 0. The next piece, the y-intercept, we'll come back to that. Someone say the degree, please. They said it over there.
4. Wait, I think it's 1.
So again, with the parentheses, if it's in factored form, you add up the exponent on each one of the parentheses. And so in this case, it's a 4. The other one that we're going to do is going to be where you just have the x to the 4th power. You just choose the 4. X to the 5th power, you just choose the 5. Yeah.
Solution 4, 2.
So that's
Solution. Solution is 4.
Why'd you put a 5?
Because you felt like it.
I was going to do 5 minus 1, but I thought that would be too tricky, so I'm just going with the regular. Okay, alright, orientation, positive or negative?
Positive.
How do you know? Because when you look here, when you look here, there's no minus sign up front. If there's a minus sign up front, it's negative, which I think she might do something like that today. Most of it is in.
I thought it was out.
The picture is the tricky part, but let's see if we can get a y-intercept. Can someone punch in and get us our y-intercept? For those who aren't here, all you do essentially, I'm going to say a little different for you. The others, I told them they put in a 0, and then they do the work. For you, I'm going to say it this way. Cross out the x's, and whatever that number is that's left, whatever number's left, you just raise it to the 1st power, which is nothing. In other words, 6 to the 1st power is just 6. 3 is just 3. Negative 5 is just negative 5. In other words, the 1st power doesn't change it. You multiply them all out, and whatever answer you get your y and your
negatives?
I don't know.
It'll be negative though. No, it'll be
Once you punch all 4 of those to your calculator,
by negative 5.
3 and the 6 and the negative 8, 5 and negative 8.
We do.
So again,
You know I'm not good.
all of these pieces are easy. The problem is just there's so many pieces.
Yeah. Are you saying that I will?
720?
Yep.
All right.
Wait, you multiply them all?
Yeah.
Also, on the
Close enough.
Well, she's almost there.
You must write it as an ordered pair, though. And when you get the y-intercept, you need the number to be in the y slot. and the other 0 will be in the x slot. Just like with the x-intercept, you have the numbers in the x slot and the zeros on the other side. All right, let's see if we can draw this picture. Oh, do this for me next to the number 4 for the degree. Draw that image, please. There's a 1, 2, 3, 4 for those who weren't here, or whenever you're drawing a degree, you always start with an arrow pointing to the upper right. Then if you need a 3, you just back up. 1, or rather, it's 1, 2, 3, if it was a 3, but this one is a 4, so you go up one more time. So for those who weren't here to draw the image that you're going to get here, a 4 is a W, a 3 is an S.
You did your left foot.
All right, last piece, the hardest piece. This part you need. Put in your zeros along your x-axis and see where they go. You can estimate. Get all 4 of those in there. So if you need to be exact, don't stress on being exact. But if we're gonna get that after we get our picture. This is one of the standards. It's a whole lot to it, which is why I decided, you know what? I'm gonna give them the easier version, which is what I'll do for you today. Yeah, that one is gonna be tricky. All right, let me see if I can put in my dots. Let's see. I'm putting in my zeros. I need a -6. That's 3, a 5, and 8. So 6, 3, a 5, and an 8. I need I'll put a 3 here, a 6 here, a 5 here, an 8 here.
That's fine.
So take a look at mine. I didn't put in all the little pieces, but again, as long as they're kind of
Let's
reasonable.
just have this as the fly here.
All right.
Aren't you gonna put in the line yourself?
Yeah, eventually, and yeah, it's gonna do just what you're saying. The highest one. All right. The most important part. When you start this picture, because it starts as a W, you need a line that's gonna come through that 6. And it starts right here. That part looks exactly the same. Uh-oh.
Marcus, are you having a stroke?
All right, what's going on? Yes. All right, so take a look at that. The good news on this one, there's no doubles or triples. In other words, all of these are singles, so they all erase to the first power. So they'll just go right through the number, just straight through, nothing tricky. Loop around and come back up. In other words, if I'm doing this one here, I go through the 6. How far down do I go before I loop up? It's not that important. I loop down a little bit. Here comes a -3. I'm coming right back up through it. Where am I going for my y-intercept? Because the next number I need to hit is the 5.
All the way at the top.
You can just put it up here, like I know, and then write down 0,722, or rather 0,720.
Is it gonna be at a certain point on the test, or?
No, yeah, you would just, yeah, because all the y-intercepts are way too big for that scale. I'm gonna go right through that one. Coming back down, I'm gonna hit the who's next in line, the 5 is next in line. I can't even see. Come right through it, and then finish up through the air. And again, you can see it looks like a W, which is what it's supposed to look like. This is the hardest part to remember, but if you get all this other stuff, when it's time to fix your test, I'll remind you. Last part. End behavior. I'll do it in blue, end behavior. On your picture, about halfway, draw an arrow pointing to the left and an arrow pointing to the right. Those represent the X. Here's what you're going to write. When, let's see, can't squeeze out. When X, I'll put it in green, fine. When X goes to -infinity, which is what you're going to write here,
But to a positive infinity though.
this arrow on the Y
Negative infinity.
just goes straight up. That Y says Y is going to positive infinity. The infinities are just a direction. For those who weren't here last time, the X goes this way and goes that way, that's for sure, to -infinity, positive infinity. The Y can either go up, positive infinity, or down, negative infinity. So again, when I'm on this half, to -infinity, I go up. On this half, I also go up. So this one over here is when x goes to positive infinity.
Wait, what are we doing?
And behavior. So in English,
We have to do it.
yeah. In English, it just is easy. Hey, when I go to the right, this arrow goes up. That's right at the top. When x goes to the left, this arrow also happens to go up. Right at the top. Which way? They switch it to math talk. To go to the left, you go to negative infinity. To go to the right, you go to positive infinity. To go up, you go to positive infinity. If one went down, you go to negative infinity. So it's simple. You just have to use math language to write. Pause. Take a look at this one. This is going to be. Do me a favor. Do me a favor. We're going to put the number 3, 4,
I think I have this.
2 or 1, 3, 4, 2 or 1. Please find the 3s. Please find the 3s and find the 4s. The 2 or 1, I don't necessarily need you to mark it right away. But what is he saying? Pictures A through F. If you look at the picture, you should be able to determine if the picture represents a third degree, a 3, a fourth degree, 4. My hint to you will be there will be 2 3s and 2 4s. Below each of the picture, put down the number you think goes there. There's a 1 out there and there's a 2. I'm not that concerned about 1s and 2s because on your test, normally when it's time to sketch, they'll ask you to sketch a 3 or they'll ask you to sketch a 4. They only won't ask you to sketch the 1. Do it in pencil, that way if you're not right, you can fix it.
What are we doing? Well, I know, but I don't know.
All right, here we go. This table right up front here with Marcos. A, what is that, a 3 or a 4?
3.
Yeah, no big deal. And it's not supposed to be tricky. Back table right there with Ashley, letter B, what you got?
Pretty good, though.
That's a 3. Coming right across Richard and Anissa, C, the 4. And then right up front here,
That was a 2.
it is a 2. Anyone now on E? Yeah, it's a 4. It's a W.
Oh, well, no, I got this one. I got this one.
And it's a 1.
It's a 1.
Nice.
Oh,
Now,
we're supposed to put everything.
now, technically, at some point, we would connect that up with the actual problem at the top, which I was kind of saying.
Sorry.
All right. What's the difference between A and B? They're both 3s. What makes the difference between A and B? One's positive and one's negative. When you're looking up here for your answers, which we will eventually, because I want this to be one of your 6 pages. Let's see if we can find a 3. Up here, numbers 1 through 6. Name one of the 3s if you can find it. A degree 3. Numbers 1 through 6. Number 2 is a degree 3. I'll put that. What's the other one that's a degree 3? 3 is a degree 3. Now, if someone's looking like, how can you tell? If it's not in factored form, if it's in standard form, find the exponent. That's a 3. That's the highest exponent. Boom, you're done. If you are looking in factored form, if there are 3 parentheses, then normally that will be a 3 unless one of those parentheses has a power of 2 or a power of 3 on it. Then you have to add them up as the numbers become bigger. So take a look and see if you can tell why a 2, problem number 2 is a 3, and why problem number 3 is a 3.
I see.
The real question that we have to decide is, now that we know the answer down here, A and B, does A go with number 2, or does A go with number 3?
Number 3 because of positive orientation. No, because it starts off negative. Right? No?
It's a little tricky. Let me say it this way. The official 3 that when we draw it looks like this. The official picture when we draw a 3, we start a 3 like this. We back up and we go down. This is the first 3 that we ever draw. It has a positive orientation. In other words, it's going up from left to right. As long as you're going up from left to right, you have a positive slope. If you were going down from left to right, which B is doing, you will notice here the picture for B is kind of the opposite. It starts up here. It's the mirror image. So what is he saying to you? You need to know what the positive version looks like. You need to know what a positive 3 looks like. A positive 3 starts low, ends high. So A goes with number 2. Put in number 2 for that one. And then B, how can you tell B goes with 3? This negative sign here tells you that the orientation is going to be negative. In other words, you're going down.
That's what he is number 3.
Do the same thing for C and E. Choose the correct. Well, first let's do this. Someone who has an answer. Name one of the 4s on number 1 through 6. 4 is one of them.
And number 6.
Okay. Those are correct. 4. Get the 4. And number 6 is a 4. How can you tell? The exponent on that 3 right there. And there are 1, 2, 3, 4. Alright, choose the correct answer though. Don't say it out loud yet. Choose which 4 goes with C and which 4 goes with E. My hint will be the official picture for 4. That's the official picture for 4, the positive version. For 6, that'll be the computer version, which is why we have the computers. Yeah. Unless they give it to us in factored form, we use the computer. There's a long method, but I decided I'll do the computer version. Alright, so let's see what I heard people say. C goes with what number?
6.
6 is correct because of the orientation.
I was right.
And
C6.
E goes with number 5.
Oh, you suck my shit.
Take a look, see if you have any questions. Uh-oh.
Wait, no, I thought E was no. D is 5.
Sorry. Correction. 6 and 5 should switch. So I'll say it this way. If you look at 6, the first term, the coefficient of the largest exponent is positive, and so everybody's pointing up. The positive version. Where's the other guy? Oh, that's negative 3 out front.
That's why I put C.
Yeah. The negative,
You mean E is number 4.
yeah.
Yeah.
Is that I mean?
Go
What I
5.
mean, I put 5, should be 4. Anybody else want to be confused?
Okay, so C is number 4, E is number 6. No, C is number 6. No, C is number 4.
No, C is number 6.
Then why does it have number 6 in there?
Oh, yes, C is number 4.
Yeah.
Just pause. C is number 4. Alright, everyone chill. C is number 4, and E is number 6. Because 4 starts off with negative, and C ends in negative.
I still didn't know what that.
Alright, I'm good there. Hopefully somebody's writing in pen. Now you know why you shouldn't write in pen. E is 6.
I changed it like 4 times, going on right.
Look at it one more time to see if I put the right number.
4 is good. Can I guess which one number 1 goes to?
Number 7? No, alright,
Can you guess which one number 4 goes to, Thomas, please?
go ahead, guess. Go ahead and guess.
Alright, F.
Who wouldn't have thought of that shit?
4 goes with F?
Yeah. Number 1, because it's a 1.
I always think people
Oh, my bad. 1 goes with F.
like a lot.
Now again, on that, it's true. I mixed it up a couple times, so let me say it properly. So C really is number 4. That is, it's going down. The exponent or the sign at the very beginning is negative. And then of course E really is a 6, so the first exponent is positive. Alright, let's do the computers. Open up your computers now. Write in degree, orientation, solution, group, y-intercept, and behavior.
Is this in factored form? It's not, right?
Oh, standard.
Yeah, it's standard, but you're going to end by rewriting the factored based on what your zeros are. They don't have decimals, they'll look weird, but you're still going to write the factored form. Again, this problem ends with you writing the factored form. Click on your X's.
I
Anything else I need on here? My y-intercept. Don't make the mistake of making your y-intercept an x-intercept.
Math isn't real because the numbers we use for math don't exist in the tangible sense.
Alright, let's see if I can put this in on my thing. Can I move it over this way?
One ceases to be and it becomes two-ness. Tangible. Two-ness is an equality of rather valueless because there are two that just...
4 tables. Let's see if I can get those.
They were really
Oh, no.
The office.
Oh, and I won't do it for me.
You're apparently being in space can change your data to
You talk.
Easy question. Here we go. Let's get all this one in and give you your test. What degree is this one? Degree?
4.
4. Someone different. Orientation? Negative. Number of solutions?
4.
Alright. Someone different. Now we'll go 1 per table for a 0. So that way each table gives one. Give me the, going from left to right. I'll start here with Marco's table. Give me that first 0, please. Back table, the next one in line, going from left to right. Okay, I see it. Back table, give me the third one in line. Skip over that y-intercept.
0.1433.
Uh-huh.
I can't round it up.
That's fine. And up front, please.
2.10.
Y-intercept. Someone say it.
0.5.
All right. We now need to write out the problem in factor form. This one I'll just write. You check and see if you have it. I recommend doing the f of x just like they have.
Oh, okay. I feel y, but...
Or y equals, yeah, y equals is fine. Alright, here comes, it's going to be an x plus that 2.3. It's the opposite sign with a plus in between. The next one is x plus that 0.233. Third one, is the third one plus or minus? Minus that 0.44. And then that last one. Oops, come on, you can do it. You can do it. Where are you? You're a 4. And the last one is a x minus a 2.1. Is there anything we're missing?
No.
Oh, and behavior, and behavior. And behavior always begins the same.
Negative, infinity, positive.
Uh-huh.
So there's negative infinity for everything, right?
For the x's, you do x goes to negative infinity, x goes to positive infinity.
So what? How? It goes back down, though.
No, I'm just saying, when you begin, you start with the two x's. X goes to negative infinity, it's going to be the first line, then we'll decide what
Okay.
And then x goes to positive infinity, that's that side. So you always begin with that for the x's. Let's see, so they're both going down this time.
It's negative.
So y is also going to negative.
So not only on the left side does it go to negative infinity, but like Sam is saying, on the right hand side is also going down to negative infinity. So here it comes. When x goes to the left, y goes down. Math talk for down is negative infinity. And when x goes to the right, the blue arrow goes to the right, the y also goes down.